In today's presentation, we'll be discussing how cyanobacteria has affected Lake Erie. Lake Erie is one of the Great Lakes. It is located beneath Lake Huron and Lake Ontario, with a whopping area of 25,744 kilometers squared and an average depth of 19 meters. This lake is home to many fish like walleye, perch, rainbow trout, and more. Many people live on property along the coastline where they can enjoy the luxuries that come with the beautiful scenery of the lake and water activities such as fishing, swimming, and boating. What most people don't know is that Lake Erie has been fighting to keep its beautiful waters clean for the past decade. Lake Erie has been plagued by a bacteria that is so potent and so hard to get rid of that you can now see the effects that have taken a hard toll on the ecosystem within the lake.
So what is cyanobacteria? Cyanobacteria is a prokaryotic cell that lives in aquatic systems. They are photosynthetic organisms, meaning they produce their own food with sunlight. With the help of elements like phosphorus and nitrogen, they grow and can reproduce at incredibly fast speeds. Cyanobacteria are the most problematic organisms that are in freshwater ecosystems. They affect the water by giving it an odor that smells like mud and give the water a taste of mold. These small organisms create cyanotoxins as well. If ingested, these cyanotoxins can cause liver failure as well as kidney and nervous system problems. So where is the cyanobacteria coming from?
Cyanobacteria need certain conditions in order to thrive. They need extensive sunlight, warm temperatures, and certain chemical elements like phosphorus and nitrogen. Lake Erie provides the perfect conditions for cyanobacteria breeding grounds. The main source for phosphorus and nitrogen compounds for the cyanobacteria in Lake Erie come from the Maumee River. The Maumee River runs from Indiana all the way through Ohio and discharges into Lake Erie. The river is over 220 kilometers long and has a discharge of 150 meters cubed per second. This river goes through lots of agricultural land, which makes it a dumping ground for phosphorus and nitrogen, which are what happen to be the two elements that cyanobacteria thrive on. This river is a concern with scientists due to it being the main source for cyanobacteria spawning. This picture shows how the river twists and turns through all of the farmland. The phosphorus and nitrogen are generated from the fertilizer that is sprayed on the farmers' crops. The phosphorus then disperses through the land where groundwater picks up the pollutants in the soil and puts them in the Maumee River. This river then gets contaminated with those elements and creates cyanobacteria blooms within. The water that's in the river then travels through all the way to the southwestern mouth of Lake Erie. There are other rivers that connect to Lake Erie that also produce cyanobacteria and phosphorus and nitrogen dumps. There are 13 major streams and rivers that flow directly into the lake, including Portage, Sandusky, Chahaga, and the Grand Rivers of Ohio, the Catawbaras Creek of New York, and the Grand River of Ontario. Dr. Jeff Reuter will talk a little bit about how cyanobacteria have affected Lake Erie.
Dr. Jeff Reuter has been researching harmful algal blooms on Lake Erie for over 40 years.
Lake Erie is the southernmost, the shallowest, the warmest of the Great Lakes. It receives the most nutrients, so biologically it's the most productive of the Great Lakes. But it's possible to have too much of a good thing.
Nutrients like nitrogen and phosphorus found in sewage and fertilizer overfeed the algae, and the lake, made warmer from climate change, provides a comfortable environment for the algae to thrive.
Well, when you put nutrients into water, it responds very much the same way as putting fertilizers onto our lawn. It makes the grass grow. when we put nutrients into the lake in the summer, when it's very warm, would be when you would expect to get blue-greens or cyanobacteria, and they are capable of producing toxins that can harm people, harm animals.
The reeutrophication of Lake Erie can be contributed to three factors: the introduction of invasive species to the lake, specifically invasive mussel species, rising water temperatures, and phosphorus loading from agricultural land runoff. These all contribute to the introduction and thriving conditions for dissolved reactive phosphorus, which is explained to be the main contributor to the reeutrophication of Lake Erie. How climate change affects algal blooms. Well, the resistance to zooplankton grazing in some genus of cyanobacteria, specifically microcysts, promotes the occurrence of cyanobacterial harmful algal blooms, or CHABs. Climate change is likely to further alter zooplankton grazing as increased temperatures shift zooplankton communities to smaller and more selective species. With the increase of water temperature, Cyanobacteria taxa will thrive due to their adaptation to warmer temperatures, while phytoplankton taxa will decrease since they aren't adapted to these new conditions.
The harmful algae bloom samples, also known as HAB grabs, are extremely important because they show us what is in the drinking water. Townships will carry out these samples from the lake to determine what toxins are released from the algae blooms and when microsystems are at their highest, which help them create do not drink advisories. Many towns and cities around Lake Erie do this, like Toledo, Ohio. These do not drink advisories happen almost annually ever since 2011. When these advisories are announced, residents have to drink and shower with filtered water from water bottles and gallon water jugs because their tap water is contaminated. Most potable water and wastewater treatment plants cannot handle the extreme amounts of cyanobacteria that have been occurring within the last decade. Their filters get clogged with cyanobacteria and the water will have a greenish color. Here is a news report about Toledo's affected water.
That prompted the governor to declare a state of emergency today and a warning to hundreds of thousands of people not to use the water. It's happening in and around Toledo. NBC's Miguel Almaguer has the latest.
The camps waited 3 hours with 60 other desperate families to finally get what they came for. One case per family of clean drinking water for 4-year-old Todd Jr. and his 1-year-old sister Michelle. They live in Toledo, Ohio, where tonight families are waiting in line and living in a state of emergency.
Orderly fashion, please.
The water here isn't safe to drink.
I am very concerned for my kids because I don't want them to get sick.
The run on water started just after 2 a.m. When the city announced tap water was dangerous to consume, store shelves went empty in hours. Lines at grocery stores wrapped around the block. Some drove from Ohio to Michigan for a case of water. Police called in for crowd control.
So far, there's no real panic, but people are very concerned.
Lake Erie, a major source of drinking water for Toledo, may have been impacted by a harmful algae. The city's water treatment plant serves 400,000 people, an area spanning 100 square miles. Restaurants have been shut down. The University of Toledo and the zoo are closed.
We are issuing this alert because the level is above the safe level for ingestion.
What are the health risks of cyanobacteria if ingested? For any human that comes in contact with cyanotoxins can experience some of the following health effects: abdominal pain, headaches, sore throat, vomiting and nausea, dry cough, diarrhea, blistering around the mouth, fever, or even respiratory paralysis, which can lead to death. Respiratory paralysis is caused by cyanotoxins that are found in the most common cyanobacteria in Lake Erie. These effects are also more prominent within animals that live in the lake. The treatment for people who have been exposed to cyanobacteria toxins is quite extensive. Humans who come in contact with contaminated water need to contact the Center for Disease Control and rinse yourself of the water as soon as possible. They also must seek medical attention right away if the symptoms previously discussed arise. This is a table that shows the different cyanotoxins and the most common cyanobacteria that releases them. The health effects based on what cyanotoxins cause which symptoms for humans is also shown in the table.
Cyanobacteria causes many health risks when a human or animal comes in contact with its toxins. There are 3 stages of a cyanobacteria bloom, and each state will affect an organism in the water differently. In the pre-bloom, water with extensive nutrients is ripe for cyanobacteria growth to occur. The second stage of the bloom is an overabundant amount of chlorophyll from the cyanobacteria that makes the water very murky and hard to see, blocking the light from the sun, making it unable to reach the plants within the water system. Last is the post-bloom, which is where you will find most eutrophic lakes because there is no oxygen. The water is murky with decomposing bacteria and depleting oxygen. The fish either die with the bacteria clouds and suffocate, or they move to a different area that does not have as much cyanobacteria for a better chance at survival. High amounts of cyanobacteria blooms, whether they are toxic or non-toxic variations, can lead to very low oxygen levels in the water. This results in higher mortality rates in local shellfish, fish, invertebrates, and plant populations. Other cyanobacteria blooms from different species of cyanobacteria can lead to inhibit titin of other phytoplankton and suppression of zooplankton grazing, which most fish and smaller organisms feed on. If the small organisms were to dissipate, then the whole ecosystem chain would fall apart, leading to reduced growth and reproductive rates within the ecosystem. Are there any possible solutions to fix Lake Erie?
A study conducted by Justin Adam Myers of Wright State University in 2019 concluded that periodic mix can also affect algal blooms in a lake. The lower the turnover rate, the greater the phosphorus problem can be solved. With the agreement between Canada and the US to reduce phosphorus in the lake by 40%, the reduction efforts of both countries can solve the problem.
A possible solution to the cyanobacteria blooms in Lake Erie would be by restoring the Great Black Swamp in Ohio. An idea by William Mitch proposes that by restoring 20,000 to 40,000 hectares of the Great Black Swamp could fix Lake Erie's problems. Historically, the lake used to have over 400,000 hectares of swampland, but no longer does due to agricultural land taking over. Southern Lake Erie suffers from nitrogen and phosphorus deposits, and by putting the swamp restoration plan into effect, the wetland would be able to filter out the phosphorus and nitrogen before it reaches the main parts of the lake. By doing this, it could potentially reduce phosphorus loading by 480 to 960 metric tons annually. This restoration project could potentially be Lake Erie's savior.